A pleasant day, everyone. Welcome to our discussion for today. So, our focus for today's discussion is on the differentiation rules. So, last time we discussed about power rules, sum and difference rules. We have the product rules, quotient rules, and we also have the chain rule. So, today I'm going to review of what we had discussed last time, and at the same time I'm going to give you some of the examples, additional examples. So now we'll focus first with the power rules, but actually our examples today after the previous examples will be some combinations of sum and difference as well as the power rules. Okay, so we have here the power rule. So we'll focus more on this rule in differentiation. So last time we have this example. Okay, so example number 1. So I'll just repeat what we had last time. If you are given, for example, a function of x equal to x cubed. So what is our answer here? So in our discussions on power rule, if you're given f of x equal to x to the n, so to find the derivative of the function, we call it f prime of x, so equal to, so the exponent here, this is the n is the exponent, x is the base. So the rule is you bring down this exponent, okay, and then multiply it with the base. Then our exponent now should be minus 1, n minus 1. Okay, so this is our power rule. Alright, so using this power rule, so this is now our solution. So derivative of the function, or we call it f of x, derivative of function of x is equal to, so the power will go down, so we have 3, then multiply it by the base, or with the base, which is x, then the exponent or the power, you subtract it by 1. So therefore f prime of x, or the derivative of x, equal to 3x squared. So this is the answer. Then we are also given number 2 example. So we're given f of x equal to x to the power 4. So using the formula again, or the rules in differentiation for the power rule, so we have f prime of x equal to, this is 4x cubed. Alright, so that's the step-by-step solution of the example that I have shown you last time. Now let's take another example, a little complicated compared to the previous two. So for example, if you are given, say, f of s, so our function now is a function of s equal to 4 over s minus 1 over 6 s cubed, then plus 8 divided by s to the fifth power. Okay, so how will you solve this one? So this is now a combination of uh, sum and difference rule as well as the power rule. Okay, so what is the first step in solving this problem? So the first step is to um, bring this variable up, okay, so that we can use the power rule. So f of s, so now we are not yet differentiating, we're just transforming this function into another way. So we have 4, then s, when you bring this up, s, so s here is understood to have a power or exponent equal to 1. So when you bring it up, so the power or exponent becomes negative 1. So minus 1 over 6, then bring this up, so you have s, this becomes power or exponent minus 3, then plus 8, then bring this up, so becomes s to the power or exponent negative 5. Okay, now finding the derivative of this function, so we have f prime of s, so we have to differentiate now. So we have to do it individually. So we know that we have also a rule that if you have if you're given a function of k times x, so this is equivalent to, if you have this function of k times x, so we have is equivalent to f of, or you have to put here k times a function of x. So when you differentiate this, so we have f prime of k x, this is equivalent to k f prime of x. Okay, so we will apply this one in some of this term here. Okay, so using that concept, so we can have here 4. So using the power rule for this variable s here, so we have, so the rule is to bring down the power, then multiply it by the base, then you have a constant here, so that would also be multiplied by the constant, so this would be times negative 1. So don't forget to enclose this with a parenthesis, so that indicates that this is multiplication. Then s, this time we have negative 1, that is our exponent. The rule is to subtract this by 1. Okay, then minus 1 over 6, 1 over 6, then we have the exponent or power, you bring it down, so negative 3, so again you have to enclose this with a parenthesis. Then s times s to the power minus 3 minus 1, then plus, we have 8 times, bring this down, minus 5, then multiplied by s to the power minus 5 minus 1. Okay, so we are following the power rule and together with the other rules. So next we are going to simplify this. So f prime of s, so be careful, don't forget to write this f prime of s, otherwise we can think of it as f of s. F of s is different from f prime of s. F prime of s means this is the derivative, Okay, so we have here 4 times negative 1. So that would be negative 4. Then you have s times s, so 4s raised to a power negative 1, negative 1, or negative 1 minus 1. So this is minus 2. Okay, then we have negative times negative, so this becomes positive. Alright, and we have 6 at the denominator, minus 3 at the numerator, so you can take the factor of the 6, which is 3 and 2. Alright, then 3 divided by 3, so what is left in this part here? So we have 3 divided by 6, so that would be 1/2. Then s to the power minus 3 minus 4, minus 3 minus 1, so this would be minus 4. Then we have positive 8 times negative 5, so this would be minus 5 times 8, or 8 times 5, that is 40. Then s times s, then the power would be minus 5 minus 1, so this is minus 6. Okay, so this is our answer for this problem. Is it clear? Alright, so we have here the first 3 examples. The first 2 of these examples were given to you last time. So this time we have additional one, and I'll give you one more just to emphasize these rules, the first 2 or 3 rules. Okay, so another example. So example number 4. So if you're given, say, r as a function of t equal to 6 divided by square root of t cubed, then plus 1 over 8 times t to the 4th minus 1 over 3t to the power 10. Okay, so this is our given function. Our function is a function of t. Alright, so what is our first step here? So to solve this problem, like in our example number 3, we have to transform them into another presentation. Okay, so the first step here is to express first the term that contains the radical in terms of a rational exponent or rational power. Alright, so rewriting this, we have r as a function of t equal to, we can rewrite this as 6 divided by, our variable is t, and we know that this is square root. Square root, if you can still remember in our previous discussion, it means power of 1/2. Okay, everything, the radicand, if you have the square root of a radicand, you can express this as radicand raised to the power of that index. So if this is square root, the index is 2. So it means when you translate that into an exponent, so this will be 1/2. If this is 3, 1/3. If this is 4, 1/4. Okay, and so on and so forth. So we have expressed this in this manner. So 6 divided by t cubed raised to the power 1 half. Then plus 1 over 8t to the 4th power minus 1 over 3t to the 10th power. Okay, so the next step is the same as in our example number 3. We need to put this variable above. Okay, and the rule is if this is positive, the exponent is positive, then it becomes negative when you put it above. Okay, so same for all these terms here. But before we can do that for this first term, so we have to rewrite it first as 6 over. So we have power and then another power. So the rule in the law of exponent, if you have, say, x to the power m raised to a power n, this is equivalent to x to the power m times n. So you have to multiply the two powers or two exponents. So this becomes 6 over t to the, so 3 times 1 half, so that is 3 halves or 3 over 2. Then plus 1 over 8t to the 4th power minus 1 over 3 times t to the 10th power. Then same in our example number 3. So we have to bring this up. We have 6 times. When you bring this variable with the exponent up, so this becomes 6 times t to the negative 3 over 2. Okay, negative 3 halves. The exponent now. Then plus 1 over 8. So you just bring up the term that, the variable, no, not the constant here. So we have 1 times t to the negative 4th power minus 1 over 3 to the, where you bring the t above, so t to the minus 10. So 6t to the minus 3 halves, then plus 1 times t, that is t, or 1 times t to the minus 4, minus 4 to the 4th power, negative. Okay, so this is now our new presentation. Minus 1 times t to the minus 10 is equal to t to the minus 10 divided by 3. Okay, so this is our r as a function of t. Now for the derivative, so when you write now the derivative, so you don't forget to write it this way. R prime sub t, meaning this is the derivative of the function t. So we have 6, then applying the power formula, so the power will go down. So 3 over 2 or 3 halves, then times t to the minus 3 halves minus 3 halves minus 1. Okay, because you subtract the powers by 1. Then plus, we have, this will go down, so we have minus 4. So you have plus here, but your exponent here is minus, so minus 4, then times t to the minus 4 minus 1 divided by 8. Then minus, okay, so minus, and then you have this minus 10 will go down, then times t to the minus 10 minus 1. Okay, and this is divided by 3. Alright, so simplifying this, we have r prime sub t equal to, so we have 6 times negative 3 halves. So this is the same as 6 times negative 3, 18, divided by 2, 9. Negative 9, because 6 times negative 3, negative 18, divided by 2, negative 9. Okay? And then t to the, What is now the exponent? So minus 3 halves minus 1. So what is minus 3 halves minus 1? So minus 3 halves minus 1 equal to, so find the LCD here. So LCD is 2. This is understood to be over 1. So 2 divided by 2, 1. 1 times negative 3 is negative 3. 2 divided by 1 is 2 times 1, or negative 1. So negative 2. So therefore, this is equivalent to minus 5 halves. Okay? So the exponent now for the first term for t is equal to minus 5 halves. Then you have plus minus. So plus times minus. So this will be minus or negative. Then you have 4 divided by 8. So what is 4 divided by 8? So that is divisible by 4. So divide this by 4. 1 divided by 4. 2. So you have 1 half. Okay, so again, the numbers are divisible by 4. The common factor is 4. So negative 4 or 4 divided by 4 equal to 1. Then 8 divided by 4 equal to 2. So plus times minus, so minus. Then we have here minus minus. So that becomes plus. Then we have 10 to the, times t to the power negative 10 negative 1, meaning minus 10 minus 1. So this is minus 11. Then divided by 3. Okay, so this is our answer. So I'll just rewrite this one just to make it clearer. No, we have a derivative of a function r as function of t is equal to minus 9 t to the negative 5 halves, then minus 1 over 2. Sorry class, we still have t here. So t to the power minus 5. So 1 half t to the minus 5. Okay, then plus 10 over 3 times t to the minus 11. Okay, so this is our final answer. Okay, so I hope you have learned something today, and at the same time reviewed what we had in our previous lecture, previous video. So thank you very much. If you have any question, you just message me, or you just comment on the section below. Okay, so have a nice day, and see you again in our next discussion on the next rule. So this time we just finished the power rule, and next rule will be discussed in the next video. Thank you, have a nice day, and keep safe and healthy everyone. God bless. Bye for now.